All right, 8th graders, we're going to talk about inscribed angles in section 11.4. So we're going to start with what is an inscribed angle. So an inscribed angle is an angle whose vertex is on a circle. So let's just stop there and look at this picture. If you look here, the vertex of angle DEF is on the circle. So because it's on the circle, it's considered an inscribed angle, and whose sides are chords of the circle. So as you can see here, segments DE and FE are chords. An intercepted arc consists of the endpoints that lie on the sides of an inscribed angle and all of the points on the circle between them. A chord or arc subattends an angle if its endpoints lie on the sides of the circle. So let's look at what we have. Angle DEF is an inscribed angle. Arc DF is the intercepted arc. So that is the arc that is across from the angle. Arc DF subtends angle DEF. So let's look at theorem 11.4.1. This is the inscribed angle theorem. Now before we talk about this thing, we're going to just look at all three different cases. As you can see in case 1 is where one of the chords goes through the center, which is the diameter. Here we have the center, which is between the two chords, and here we have the center, which is outside the two chords. All of them are inscribed angles because the vertex, which is point B, is on the circle. Now here's our rule. The measure of that angle is half the arc. That's it. So the measure of angle ABC in all of these cases is half whatever the arc is. So let's just say I have a circle. In that circle, let's call the center X, circle X, and we have this angle, and I say the arc is 80 degrees. If the arc is 80 degrees, and let's say that arc is AB, then that means angle ACB, that would be 40. The inscribed angle is half of the arc 80 degrees. So why does that work? It works because of this. So look at ABC. ABC is an inscribed angle. We want to prove that this angle, ABC, is half of the arc. This is important. I am proving to you why that inscribed angle is a half of the measure of the arc. Here's why. If angle ABC is inscribed, which it is, we're going to draw point X and we're going to connect it with segment AX. Well, what do we know about this? This is important. I have the circle. That right here is a central angle, and that's equal to that arc. So here's what we would say. By the exterior angle theorem, the measure of angle AXC is equal to the measure of ABX plus the measure of BAX. So let's look at that again. The measure of angle AXC, this angle here, is equal to the measure of angle ABX, this angle, and BAX, which is this angle. And how do we know that? Because that's what we learned a long time ago, that the exterior angle is equal to the two remote interior angles. Since segment XA and XB are radii, they are congruent. So we know these two angles are congruent. By definition of isosceles, that means these two angles are also congruent. So because these two angles are congruent, we know ABX is equal to BAX. And we just said that, they're congruent because it's isosceles. By substitution, the measure of arc AC is equal to twice the measure of angle ABX, because we know this is half of this. Therefore, half of measure of the arc AC is the measure of angle ABX. In example 1, we're going to find each measure. So let's start with the measure of RST. So RST is this angle right there. Well, what do we know? The arc across from it is 120. Because it's an inscribed angle, I know it's half. So the measure of angle RST is equal to half of 120, which is 60 degrees. The arc SU, so SU is across the inscribed angle of 40 degrees, so that means I double it. So the measure of arc SU is 80 degrees. Easy. So now we're going to look at corollary 11.4.2. So here it says, if we have inscribed angles of a circle that intercept the same arc, so we're going to stop there. I want you to look at arc AB. It's in yellow. The inscribed angles ACB, ADB, and AEB all give me the same arc. Because they intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. Basically, in the easy term, if you have an arc that is shared by 3 different inscribed angles, those angles are also congruent. That's what it says. All right, so in this picture, we have arc AD, which has a measure of 86 degrees, and we want to find the measure of angle DEC. So we have a circle here, and I'm going to find DEC, which is that angle. But I'm going to redraw it to make it easier. Now, because we know angle BAC, BAC is 60 degrees, the arc across from it is going to be 120. It's doubled. Now we know this arc, which is BC, right there. It shares the same inscribed angle, BDC. But wait a minute. This angle here and this angle here would have to be congruent because they share the same arc. Now once again, I'm going to put a red dot on what angle I need. That's the angle I want. But I know that arc AD is 86 degrees. Well, because the inscribed angle ACD is half that, this would be 43 degrees. Because that makes a triangle, it adds up to 180 because of the triangle sum theorem. So if I subtract the sum of 60 and 43, that is 103. And I subtract and I get 77 degrees. So the measure of angle DEC is 77 degrees. Another theorem. If you have an inscribed angle, right here, here's your inscribed angle, big arc. But if you connected the ends here, and it goes through the diameter, so an inscribed angle subtends a semicircle, if and only if it's a right angle. You know it's a right angle. So I have a circle. Anywhere in that circle, I have 2 arcs. But if you connected the endpoints of those arcs, and you make a semicircle and it goes to the center, we know it makes a right triangle. But that's a right angle. That's what our theorem states. And think about it. This would have to be how many degrees? Half of a circle, so it's 180 degrees, which makes the angle here 90. Let's do 2 examples. Find x. Piece of cake. Because we know this inscribed angle, it makes a semicircle here. We know that 4x plus 6 is actually a 90-degree angle. So you would do 4x plus 6 equals 90 degrees. I solve the equation, subtract 6, divide by 4, you're going to get 21. So the value of x is 21. In B, the measure of angle ADC, this angle here, is what I need to find. Well, what do we know? We know that ABC and ADC have the same arc. Therefore, these angles here are going to be equal. So I can set 10y minus 28 equals 7y minus 1. We solve this, which is completely review. Y would equal 9. If y is 9, I plug it into the measure which is 7y minus 1, which would be 7 times 9 minus 1. So the measure of angle ADC is equal to 62 degrees. And lastly, theorem 11.4.4. If you have a quadrilateral that is inscribed in a circle, the opposite angles are supplementary. Not congruent, supplementary. So angles D and B would be supplementary, and angles A and C would be supplementary, but only if that quadrilateral is inscribed in the circle. So in example 4, I want to find all of the angle measures in that quadrilateral. So I want to find the measures of angle P. Let me rewrite that there. The measure of angle P, the measure of angle Q, the measure of angle R, and the measure of angle S. So what do we know? Opposite angles are supplementary. So that means angle P and angle R are supplementary. So 6y plus 1 plus 10y plus 19 equals 180. I solve this equation. 16y equals 160. Y would equal 10. If I plug it in, the measure of angle P would be 61 degrees. The measure of angle Q would be 100 plus 48, so 148 degrees. The measure of angle S would be supplementary to that. It's supplement, so this would be 32 degrees. And the measure, that's S. S is 32 degrees. And the measure of angle R would be 119. So there would be all 4 angle measures. Your vocabulary would be these 3 terms: